All right, we'll go ahead and get this kicked off here since we're at 5 after the hour. Welcome, everyone. Thanks for joining. Brendan Dalpe on the SE team presenting today for the office hours on Logstream in AWS. So we won't get into some of the basic stuff here. We're actually going to go from 30,000 feet right to ground level pretty quick. What I would like to highlight today is some of the things that we can do in Logstream around auto scaling, deploying as containers in AWS, and leveraging a lot of the cloud native features that are available to be able to take advantage of cost savings and optimizations in AWS. So with that, a little primer here on the AWS services. There's a few acronyms that I will be throwing around quite a bit here in this presentation. So I figured let's get those out of the way here. EC2 is Amazon's Elastic Compute Cloud. This is the virtual machine side of the house. So when you think of AWS, this is what most people think about, running virtual machines in the cloud. There's another service that we're going to be talking closely about, ECS, the Elastic Container Service, and this is the hosted Docker in AWS. And there's also a equivalent service, EKS, the Elastic Kubernetes Service. We won't be talking about that today. We do have some Helm charts available on our Cribl GitHub if you would like to deploy Logstream on Kubernetes. All the auto scaling is built in there, but this is going to be on ECS, roll your own type deployment. We'll also be talking about ALBs or NLBs. These are application or network load balancers, respectively. So Amazon's managed load balancer service. ASGs, I may refer to auto scaling as an ASG, and that is ultimately, a collection of EC2 instances that are running as basically a dynamically scaling group. And then there's another item here. Just want to make sure that a lot of this leverages is CloudWatch metrics. So being able to see things like CPU and memory utilization, and this is what drives the auto scaling groups. Ultimately, to be able to set thresholds to say, I want to be able to maintain a certain level of performance in either the ASG or the ECS service. And that ECS service is the equivalent of an auto scaling group, by the way. So I always like to say this: nobody runs at full capacity all the time. My background is, having done Splunk professional services for quite a few years, I never worked with a customer whose ingest was flat across the board all day long. We could provision capacity and say, this is exactly what you need all 24 hours of the day, 7 days a week, 365 days a year. Things are seasonal, things are daily, things are periodic, cyclical. So being able to leverage cloud in such a way where, quite honestly, does your ingest look like this? Because I pretty much can guarantee you it looks like this. So when you look at the cloud and being able to leverage things like auto scaling, the top line is typically what happens for most deployments. When you think about traditional data centers, I need X servers, I need these servers to have a certain number of CPUs and memory available for them. You then provision for the peak load that you're going to have within your application. But quite honestly, you're not performing at that level 24/7, 365 days a year. This sinusoidal wave here, or the wavy line, that's really what the demand looks like for ingesting data, processing data. So, setting it in between these two lines, you either over provision or under provision. So being able to leverage things like auto scaling groups to have that elastic capacity, you can step your available resources with the demand that you have. So what ends up happening is something like this, and we'll talk specifically about EC2 here, but the equivalent applies for ECS. Amazon will monitor the auto scaling group using CloudWatch metrics. So we're looking at CPU, we're looking at memory, and we're saying, based on a couple parameters that I can define inside the auto scaling group, what is the minimum size of the group? You could say 0, 1, 2, I mean, whatever the instance count is, you could say potentially 1, in this case, log stream worker is the minimum to process data. We always want to have a worker available. We can have a desired capacity to say, try to keep 2 instances. I'm referencing on the left here. So minimum size 1, desired 2 for redundancy. And then we can define maximum capacity inside this auto scaling group. So scale up to a certain amount and then stop. Don't scale beyond this. This could be for cost measures, cost controls, etc. So this really watching how much is each of these workers using in terms of CPU. And over time, then either stepping up, stepping down, or remaining constant to be able to scale out and scale in as needed. So defining this auto scaling group to basically deploy your instances evenly across things like availability zones. Say availability zone is having a bad day. We could scale out in the other 2 availability zones to continue to process the data that's coming in at the appropriate rate. Pause here for a second before we go to the next slide. Any questions from the room? Feel free to shout at me. Happy to answer any questions at any point, or post it in the chat, and I'll answer those too. Also pause so I can take a drink of water. Cool. So I do want to provide a little comparison why EC2 versus ECS. And ultimately, this is going to be on what the use cases are. So EC2, you're maintaining the underlying infrastructure. So you get virtual machines from the auto scaling group. You're maintaining the patches for those machines. You're putting any agents on those machines. Really, it's yours to do whatever you want. One of the benefits here for EC2 is you can leverage what's called spot fleet. We'll talk about that in a second here, but spot fleet allows for additional cost savings by leveraging things like spot instances, which are much cheaper than on-demand or even reserved instances. Whereas ECS, all you're maintaining is the container image. So you can either pull from the Cribl Docker hub, where we have our log stream instances. You say, I want log stream version 301 or 302, which is generally available now. This allows for a quicker scale up and scale down. You're not thinking about infrastructure. You're not thinking about virtual machines. You're thinking about, I am deploying a log stream worker instance inside a container. Amazon handles all of that infrastructure for you, and you can leverage called Fargate. Fargate is a serverless platform for deploying containers. So you do pay a little premium for leveraging Fargate, but ultimately, this is something that, then you don't have to think about what are my instances, do I have to patch them, making sure that they're available, agents installed, et cetera, et cetera. So Fargate is a fixed price, so you're not leveraging the spot fleet to get better savings, but trade-offs between what do you want to manage here. So spot fleet, link below here. This is a great introduction to what spot fleet can do, but adding basically to your auto scaling group, you can have a mixture of on-demand and spot instances at the same time inside your auto scaling group. Now, traditionally, your auto scaling group, these on-demand instances, you're going to pay the primo top dollar price to have that machine running at a given time. You can buy reserved instances. Going back to the slide earlier, this minimum size, if you're saying, I know I'm going to have at least 1 instance running, I can buy a reserved instance, a 1-year, a 3-year, convertible, whatever you want for that, and get some cost savings there. But what you can do beyond just auto scaling, leveraging the capacity you need, is also leveraging spot fleet. And spot fleet allows you to buy spot instances at a market price inside AWS. So these spot instances are basically people have bought capacity and they say, I don't need this right now. I'm going to sell this time back to somebody else, and they can buy it for, anywhere from half to 25 to 10% of what the on-demand price is. So you get some significant cost savings by running in spot. The trade-off here is these are interruptible. You get a couple minutes of notice. Hey, your instance will be shutting down. Sorry, you won't be able to use this. So, this is where you can trade off between having on demand, I need these now, these cannot be interrupted, or being able to leverage spot. And you can choose the percentage. So maybe 25% is spot, 75% is on demand. All of these are knobs and levers that are customizable for you. So what ends up happening is you're talking about price here. On-demand price, primo price, you're paying the most expensive. This is kind of out of date slide here, but it illustrates the point. The reserved instance price, you're basically telling Amazon, I'm going to commit to using this for a year. So there's some cost savings here that you get, but then really being able to leverage the spot price is where you get the most cost-effective savings. So when we go back and look at, these peaks and valleys, consider, I'll give you an example here. I worked with a customer who they had their headquarters in the US and they had a significant European presence. And so about 6 to 10 a.m., they had this big peak of data coming in, people surfing the web over in Europe. They had a proxy in the cloud and they were gathering all of these logs. And so it was a massive ingest, 6 to 10 a.m. And then it was basically quiet the rest of the day as, business hummed on. So they had to account for this large load in the beginning of the day. So really 20 hours out of the day, they had to over provision and pay for that. Whereas leveraging something like Spot, they could have processed the data as it came in much more efficiently and only paid for those 4 hours, or even on demand 4 hours versus 24 hours, all time peak provision there. So nice to be able to leverage all of these inside AWS. So let's take a look. In the AWS console, we can look at the auto-scaling group config, and then we can take a look at the ECS configuration, the container configuration. So it all starts in the bottom of the EC2 configuration here. You're seeing some of our internal lab stuff. So there's things just ignore on the screen. I'll tell you what's important here. So built-in office hours auto-scaling group here, and I've given it some details. In this case, you can configure what your desired capacity is, the minimum capacity and the maximum capacity. So this auto scaling group is running right now with one instance, and we can see that inside the log stream instance we have here. So ASG group, we can see our ASG container is available right now to process data. And I've configured both of these worker groups, the ECS and ASG worker groups, with a HEC input, and I'll show you some sample data coming in. What we do with the ASG is then provision with a launch template. This launch template is what defines the parameters of how we want to provision machines in AWS, the EC2 instances. So I can say, here's the specific AMI I want to use. I can give it an instance type, security groups, storage configuration, network interfaces, any advanced details. Like I've attached a instance profile to allow me to use Systems Manager to directly shell into the machine. But here's what I've done, and this is what makes Logstream so fun, in my opinion, is the ability to bootstrap these instances right from the master. So I'm using the user data section, and user data is run when this machine initializes on first boot. So I've passed our bootstrap command here, curl to the master or leader instance for 9000, and I've given it the token. Actually, this is not the correct version. I have the latest version here. I fixed it. So we've provided, here's the shared token, and then we've also provided the ASG group information. And so that's available when this machine starts, and it will pre-populate the cribl.yaml file, and it'll phone home to the master, the leader node. I keep saying master, I apologize, should be leader. And then it will assign itself to the appropriate group. Now, David asked a good question here. Did you have to use Route 53 for the host name? So this leader instance has a nice host name attached to it with Route 53. No, you don't have to do that. You could use the public or private IP, depending on how you architect your network or VPC inside AWS. This could be a completely private VPC. I've done this deployment where you leverage an S3 bucket inside the VPC, and you have basically the ability to download the log stream bits from that S3 bucket, and it works exactly the same. All you need to do is provide the download URL to be able to go grab the log stream bits and install it when the instance starts. So let me see if I can find this. Actually, it's the Bootstrap. Got this up on another screen, and I will pull it up in just a second here. So when you use the Bootstrap functionality here, you can provide the token like we've done, Cribl master. You can provide the group name. If you don't provide that, it falls back to the default. But because I have multiple worker groups inside my leader node here, I can tell it which one I want to use, or I could use the mapping rule sets here to dynamically define which ones I want to. But I'm leveraging the groups parameter here, and then you can also specify the download URL, and this is useful for that S3 bucket that I was talking about earlier inside a private VPC. So you can still do the Bootstrap from a completely private and isolated VPC that has no internet connectivity. So that works too. Once this is all configured, we basically say, where do we want to deploy this? What subnets, what availability zones? And then we tie this to a load balancer. So in this case, I'm using the application load balancer, and we've then tied it to a target group. So the auto scaling group will dynamically add and remove targets. These targets are the log stream workers into this application load balancer. And so then when data gets sent to the load balancer, it's automatically load balanced across here. And you could set this up. I've got this specifically for port 8088 HTTP endpoint collection here, the HEC input. And so you can configure this to be whatever you want. I've specifically done this for HEC, but you can configure just a generic network load balancer to do TCP load balancing or UDP load balancing, depending on what kind of data you're bringing in. So you could do like a syslog server over UDP through the load balancer and evenly distribute this across the workers that are inside this target group. Or you could do TCP, things like TCP JSON or TCP syslog, however you want to distribute that data. Health checks. This is a nice functionality of the auto-scaling group. We'll check to make sure that the EC2 instance is working correctly. And we'll also check and make sure that Logstream is running correctly using the health endpoint. So basically, we make a poll. In this case, we do that every 30 seconds to check, is Logstream awake? Is it listening? If it's not, if it's down, if it's unavailable for more than a specific period of time. In this case, I've configured it for 10 consecutive health check failures. It will mark the instance as unhealthy, and it will actually terminate this instance and rebuild a new one. So basically being able to make sure that these instances are working correctly. Now, Joe's asking 30 seconds best practice for the health checks. These are the Amazon defaults that I'm using here. And the reason that I'm using the Amazon defaults actually lowered this threshold. I was playing around with this earlier. When Logstream starts, grabs the config and reloads, it basically restarts the config, it was actually under, I had the unhealthy threshold set to 2, and I actually had the interval set to 5. So you had 10 seconds to apply the config, restart, and be running before it marked the instance as unhealthy. So I do recommend making sure that your thresholds are a little bit higher than you would want. Otherwise, you may be prematurely terminating instances that you don't want terminated. So I do recommend making sure that these thresholds are what you expect. We want to make sure that we only terminate instances when there really is a problem with that instance. And the other thing too is if we're unable to send data through the load balancer, we're going to send it to another machine. So we're going to retry, most likely TCP protocol, or that specific endpoint will be quarantined if it can't send the data out. So that you can also configure, if you wanted to, scale in protection cooldown periods. You could configure, I mean, all of these are available as knobs and levers to be able to customize here. So we can see kind of the activity, what's going on here. What I'm going to actually do is I'm going to spin this up and say, I want 3 workers. So you'll notice in a second here, we've requested, oops, not yet. Basically, we're going to request additional capacity and then add 2 more workers into this group. And then after a period of time, even though I've said 3, it will actually scale down this worker group because of the auto scaling policy that's built in place here. So basically saying the instances need about 5 minutes to warm up and process data before we start looking at the metrics here. You can configure this. And I've set this policy to maintain average CPU utilization of 75%. So that allows for a little bit of OS threshold and some buffer room to be able to add additional nodes. So David's asking in chat for load balancing with syslog TCP. How do you set it to balance across all the worker processes and nodes? Now, this is a great question. I hear this quite frequently. The nature of the TCP protocol, let's say you're receiving data from a very high volume source. With TCP, we're going to pin the connection to a specific worker and a specific process. So there are reasons why you may want to look into leveraging UDP potentially, because UDP can be load balanced. It's individual packets and you're able to distribute that evenly, or things like HTTP endpoint collection, or HTTP event collection, I should say, where it's HTTP posts. So we're able to receive the data in a specific payload, and that can be then load balanced across your workers. With basically receiving a high volume of TCP data from a single source, you may be pinning yourself to a specific worker process, a specific worker. And so auto scaling won't work very well. We see one instance with significantly higher utilization than others because it can't then scale out. So the recommendation, if you read through the docs, is it's better to be receiving 200 gigabytes of data from 5 different sources than a terabyte from one specific source. So we want to make sure that we're receiving the data appropriately as it's coming in and using the right protocol. David, chime in. Did I answer your question like you were thinking I was going to answer?
Yeah, and there's also like DNS load balancing, like F5, where you pretty much have the same issue where it's pinning itself on every worker process. Is there any specific way of, if you're locked into TCP, you don't have HEC, you don't have UDP, of pushing the connections across all of the available worker processes all the time with any specific type of load balancing?
I'm gonna have to come back to you on that one because I'm not thinking of anything off the top of my head right now. You may need to put something in between to break that protocol into different chunks, different packets, somehow deliver that data differently to different systems. So just
because I too follow back to the HEC as the answer, but perfect.
Yeah.
Thank you.
Yeah. And it's ultimately, it's the nature of the TCP protocol that it works exactly like it's supposed to.
Yeah, and I asked that question because it is something we hear a lot, and customers are like, "Why are you not? You claim this performance on, but we're doing this with syslog TCP," and then we already know why. And so it's something that might come up in your environments.
And ultimately, back to the comment I made, if you're receiving syslog data from a wide variety of sources and it's very evenly distributed, not a problem, because we'll then make sure that the different workers and worker processes are receiving those TCP connections. You won't be pinned to a specific process. But if, let's say you have, in this case, I'm just going to take the Panorama management interface for Palo Alto firewalls. You can centrally collect these logs into a Panorama log collection device and then send it out via a single TCP syslog stream. In this case, the load balancing will not work very well. That's kind of the scenario that David and I are describing here, where that's not going to work very well with load balancing.
Or even like an edge router, something sitting on the, that's just extremely busy internet facing versus the internal ones. Is that something you run into that same problem with? It's just so much data.
Yeah, if you can leverage, I mean, honestly, I would say UDP, that's not reliable, but it's able to be load balanced. So, weigh what is the volume of data over a period of time versus the protocol. let's see, Paul has left a comment in here. There's a feature/bug with AWS NLB and UDP streams to be aware of. If the target the NLB is sending to is removed before the NLB from the NLB before it starts failing health checks, the NLB will never reroute that UDP stream to a healthy destination. Yeah, I'm sure AWS support loves you bugging them about that, but yeah, so there's architectural decisions that you do have to consider too when you're working on this. So again, we can always discuss specific details offline in architecture sessions too. That's what we're here for.
I am looking at Nginx for other options because I believe they do offer something, but I haven't researched it enough yet to give a good answer on.
Exactly. Very cool. So now that we've been sitting here for a few minutes, if we go back and look at our workers, we now have our 3 workers inside the auto scaling group. So there's nothing that I had to do to be able to scale this out. And so if you were receiving a high volume of data coming in from these workers, you would automatically scale up and have the additional processing capacity that's required. So just for grins here, just to highlight what's going on inside the load balancer, I'm going to give us some extra time here. And I'm going to send some data. Where's my terminal? There it is. It's behind all the people and their pictures. So I'm going to send this to the ASG. So this case, we had some fun this morning with the ASCII goat here. But as this data comes in, it's being received across the different worker instances inside Logstream, because it's HTTP endpoint or event collection. I keep saying endpoint for some reason. That's not what it is. So the AWS load balancer is going to evenly distribute these events across the workers, and they'll process them and send them through the routes pipelines, whatever you've configured. So nice to be able to do that. This is basically the auto scaling in a nutshell. So telling Amazon, I want to manage a bunch of EC2 instances, and I want you to scale up and scale down based on whatever policies that we've defined. Now, there's additional stuff here we're not going to cover today, things like predictive scaling policies. So that scenario that I was describing earlier with the customer saying 6 to 10 a.m., I know I'm going to need instances. You could create a predictive scaling policy or even a scheduled policy to scale up and scale down at appropriate times as needed. The other thing that I'd like to point out is the ability to refresh instances inside the auto scaling group. This is nice because you could basically, I have some customers who they call this rehydrating instances. So every month or so, they get a new golden image and they're required to refresh. Again, Logstream workers are stateless unless you're using persistent queuing. We're not talking about that as part of this discussion here. So assuming you're not doing persistent queuing, you could blow the instance away and start over again, process the data. So this would allow you to basically say, how many instances can I get rid of at once to be able to do this rolling rebuild of the environment here. So this is nice, especially if you update the launch template that you're using for building these machines. If you're adding whatever to your infrastructure here, it's nice. So I'll pause before we start talking about ECS. Any questions from the group? Happy to answer those.
Nothing yet.
Cool. I did want to mention one thing before we jump over to ECS. We have talked about the load balancer receiving the data. So this doesn't work very well for some things like the Splunk to Splunk protocol. You should never put a load balancer in between S2S, Splunk TCP, source and destination. Just you're not going to like the results that you get out of that. It may work, it may not work. So what you can do is leverage the lifecycle hooks of the auto scaling group. And this auto scaling group lifecycle hook allows you to send notifications to things like the SNS, simple notification service. And that SNS can then be consumed by something like a Lambda. And so here's just an example. This ASG DNS handler, somebody wrote some Terraform that I was looking at here. But basically this Lambda processes the start and stop notifications to update a Route 53 entry, which is more or less a round robin list of, in this case, it would be log stream workers inside your environment. So as your cluster scales up and down, you can have the DNS entries added or removed, and you can then leverage, let's say, Splunk's output.conf configuration to reference a DNS name, and that DNS name will get refreshed every 5 minutes, I think is the default. So with that, you'll then poll, what are the workers? If a worker goes down, it'll stop sending the data to that destination, and you'll update and everything will be good. It's nice to be able to do that too. This is custom. You'd have to handle that on your own if you were doing that. Cool. So let's hop over to ECS. A little bit different here. We're not talking about virtual machines anymore. We're talking about containers. And so these containers are basically log stream. That's it. We have the more or less the processes that are required to run log stream, any of the requirements from an OS level, and then log stream is installed inside this container. So when we define a task definition, this task definition says, here is what I want to do when this task starts. And so with Fargate, we can basically define, here's how much CPU I want to provision. In this case, I've said 1 CPU, 1 vCPU, or 1024 CPU units. These are customizable based on what you want. I've just done that for the purposes of this demo. You can go, I think, up to 8 vCPUs and 16 gigs of RAM is, if I'm correct, the highest that you can do for this. So you can provision a pretty good size worker in this environment, and then memory too. So with this, you can then define your container definitions. And this, if you look, is very similar to what you would see inside like a Docker Compose file. We're mapping the ports that we want. We want the environment variable configured. In this case, we have the Cribl dist master URL environment variable. And when the container starts, it recognizes that this environment variable is here, and it says, where is the master or the leader in your environment? And so it will then, based on this string that you've configured, phone home and download the configs, restart, reload, whatever it needs to do. And there's some additional settings that you could do with your container here. I've just done the bare minimum that's required for the demo here. And there's all kinds of additional stuff that you can configure, but basically that is the only things that you need to configure for getting this ECS task role working. Now you'll notice too, very similar to the auto scaling group, we're going to define a service. So think service A as G, that's more or less the equivalence across the two services here. So I'm saying, if I click update here, we have the same exact settings. Minimum number of tasks that I can have running at a time, the desired number of tasks, I'm going to update this to 3. And then the maximum number, auto scaling, I can add policies here. In this case, I've added the 75% CPU target to my auto scaling policy. So I'm going to update this service. It's going to redeploy, and you'll see in this case here, if I look at tasks, we've got 1 task running that was previously running. And we should see in a couple seconds here, 2 additional containers. They'll provision and they'll start. Here we go. And this process is usually about 25% of the time as it takes to run or spin up an EC2 instance, just because we don't have any of the infrastructure to manage. This is Amazon's to manage at this point. So pending is the next state. So downloading the container image, and then we should see the container start to run in a second here. And if then we flip over to Logstream, we'll see this container is actually phoned home and is registered as a worker. There we go, running. So let's switch over here, look at the workers. In this case, you can actually see, notice that the ASG, we're missing 2 workers. Where'd they go? Autoscaling actually spun them down. So here comes our new containers. So the ASG said, hey, these are idle. I don't need them. Bye. And you can configure the timeout for that. After about 5 minutes, it said it's not running at capacity. We can scale these down. So our ECS, here's our 2 additional workers phoning home, and they'll be registered with the load balancer that we've configured for these containers. They're going to restart because they have HEC input that they need to apply. So if we go back here and we look at the target groups, I can then see that was the ASG. Here's so you can see the containers are registering as targets for the load balancer. And so this is how the load balancer knows where to send this data out. And this is all handled for you as part of the auto scaling functionality in both the ASG and ECS, so EC2 and ECS services. So our containers are running. We can process the data. If we look at our ECS container service here, I'm just going to do basic capture. And we're going to send the same data over to this container worker group. Here we go. ECS, hello, goats. There we go. And again, this is exactly the same. We're distributing this data across the workers inside this ECS cluster here. So allowing you to focus on, here is the container image. I can customize the container image. You could put this in ECR, the Elastic Container Repository. And this is an Amazon managed Docker image repository, or you could put it in some place like Docker Hub and reference it from there. Or you can leverage our Cribl logstream repo. You notice the container image here is Cribl, and the latest. You could specify a specific version and be able to use that. Yeah, so that's a great Mama is I think I said your name right. I hope I did. Referencing being able to leverage virtual machines and container images side by side, and you can actually mix these together inside a worker group. I would recommend making sure that they have the same CPU and memory, because that's what we're expecting. You should have at least a homogeneous CPU and memory allocation for your workers inside a worker group. But if you wanted to, you could have containers running inside a worker group and also have EC2 instances running inside the same worker group. But in this case, I've configured in such a way where there's 2 different worker groups just for purposes of this demonstration. So again, you tell Logstream based on the tag or the group information inside the environment variable, or based on the mappings that you provide, where those workers should land inside the worker groups. And then we manage it from there inside Logstream. So great stuff. A little bit less here in terms of having to maintain and levers to change with this specific deployment. Cool. That's kind of the end of what I had prepared for today. Any questions from the group? Any other ideas on topics that you would love to discuss? We can continue to discuss this at further length if there's anything else. But yeah, this
you have a cerebral connection to your brain, so we can all learn this stuff after.
That's what the recording's for. You can go back and listen to this. But yeah, I hear you on that one. Being able to do that. I think some future state stuff will be, more. Potentially YouTube videos, doing blog articles or docs articles, working with the teams on, providing that content on how to do this at scale and leverage, cost effectiveness of the cloud. Don't over provision. Use what you can to, make sure you're paying the right amount for your services.
This is great to see. I, for one, super appreciate it. I haven't gotten into the POV stages, but I think these discussions and understanding of these topics is going to definitely help me. So thank you.
Absolutely. That's what the office hours are for. We love to share what we know. Cool. Other questions, other ideas, other topics you'd love to discuss? We don't have to stick to this. I'm happy to answer anything else that you might have that's of mind right now.
Yeah, speak up, everybody. Oh, collector paths.
Oh, thanks, David. So this is some fun that we've been having lately with collector paths. I've talked with a couple customers about how to use the collector paths to be able to build more efficient collectors inside Logstream. So if, for instance, let's say S3 is an example, but this would also work for Blob, file system, or Google Cloud Storage. When you specify your path, and actually, let me pull up the demo environment because I think it makes more sense to show what's in there. Give me a second here. Apparently I zoomed in for someone. There we go. DC1 logs, collector.
You're the shared worker group, by the way. Oh, you're in the demo, never mind.
Yeah, I'm in the demo. So, with our partition path here, this is nice because we've broken this down into year, month, day, hour folders. So Logstream does collection in two ways here. And it actually makes more sense if I pull up the REST collector. We discover first the data that we need to collect, and then we collect the data. So some intelligence behind what we're trying to do here. So let's take S3, for instance. We'll reload this. What's going to happen is Logstream is going to do this in two phases. I'm going to list the contents of the S3 bucket first, and then I'm going to use this path expression to dynamically figure out what is the subset of data that I need to collect based on the parameters provided in the run settings here. So if I say last 1 hour to now, Logstream automatically knows based on the current time what the earliest timestamp should be and what the latest timestamp should be. So we will say what files match this timestamp. So this is why partition expressions are so important, especially when it comes to using time inside this path. If you, by default, create a destination, S3, let's create a new destination, the partition expression is set to host and source type as the folder. Do you see any time in there? No. So what happens is Logstream says, I have to collect everything in this bucket based on this partition expression. I have no intelligence around what the timestamps are of these files. So it's very important to leverage.
Why is that the default? Or is there a reason that the default still doesn't include time? Just ask.
That's a great question. I'm not the person to answer that one. But I'm also, it's a demo environment. I'm also happy to, submit a request for enhancement here to make this different. But I would surmise that honestly, host and source type, just being from the Splunk world, is fairly ubiquitous across most customers, and that's already set. So, having that broken out, Oh, David says that's already happening. So Mr. Jira over here is.
And I bring it up because I do this in demo environments, and I make sure I open this tab before I go to the other tab because I want to see that partition expression. That's why I asked.
And the other important thing is these meta tags, when you are able to do the reduction of not just time for the search, but if you were saying, because you could with a collector say, recover all events where the filter is _raw.includes some value. The last thing you'd ever want to do is have to open up compressed gzipped bucket files to search for values inside every single set of events that are being written. That would be extremely inefficient.
Yeah, so in this case, what you can do is some tweaking of, let's see here, where did I put this? Yeah. So I was working with somebody on community, and you can go find my previous messages with him on this. So what ended up happening was there's actually basically this. So syslog, and I'm going to type this in real time. So I'm going to fat finger just about everything. Time, and we had for year, we had time for the month, but that was it. And then there's the file name. So the problem that was being run into here is, in order to extract the events from the files based on the timestamp provided, the subset of files that would have to be collected and pulled back to Logstream was actually the entire month worth of data. And then Logstream has to open each file, scan it, do event breaking, process and do the auto timestamp extraction, and then the data is returned. So what was useful here is actually in the file name, there was a date. And so this is what I'm doing here. The file is actually the file name. It's not a folder. So as long as I don't put a slash on the end here, I can actually grab the file name out of this path. And then I can use what's called a path extractor. And this path extractor is JavaScript expression. I referenced the token from the path. So you can see file matches file. You could do this multiple times. And this doesn't necessarily need to be underscore time. This could be a filter field that you want to use. So with that, the expression over here is the field name that you want to set. And this could be multiple field names, by the way, in a single expression. Here's our field name. And here is the expression that we wanted to use. So what I'm doing is extracting from the value. The value is the value that's passed from this path here. So if I reference the variable value inside the extractor expression, I can then do some stuff with it. So his file name had a dash in it. We were taking this, the left side. We're then doing strip time, extracting year, month, and day. So we're narrowing this window from a full month worth of collection down to a day. And that was a significant amount of data that was removed from having to be collected, pulled back, processed. Because the other thing, data out of S3, if you're going back to on-prem, is not free. You're charged the egress cost, 9 cents a gigabyte. So if you're running this inside AWS in the same region, you're not charged for that. However, you still are charged for API calls. So keep that in mind too. The more files that we have to process, the more API calls that have to be made. So what happens here is we actually can set the underscore time, which is used by the earliest and latest. So we're able to narrow that window, only collect the relevant files that make sense for this. And then when we do event breaking and processing, that auto timestamp extraction overrides the value that we've set here. So a little trick that you could do for processing these files, just depending on how you have this structured. Go ahead, David.
What happens if the customer chooses, as you put it, not to use any time, and then they have a repetitive collection job running every 5 minutes relative?
Yeah, in this case, let's say you're using the default. I'm going to have to pull back all of the data inside the bucket. I'm going to have to extract all of the events, and I have to do the timestamp based on that. If there's no way to determine from the file name what any of this is, so that's a very inefficient way of storing the data inside S3. So highly recommend that you build this partition path with the cardinality that is needed to, how frequently are you pulling back files from S3? Now, in this case, what I would say is you probably should leverage the S3 source. In this case, the S3 source allows you to leverage Amazon's SQS, or simple queue service. And we can configure on the S3 bucket event notifications. So anytime a new file is uploaded to S3, it will send a message over to SQS. And the Logstream workers, instead of crawling the bucket looking for these files, get the notification from SQS. That notification has the exact file name that is new in the bucket. And then we only have to go pull that one file out of the bucket. So we do that per event notification here. This is a much more efficient way of handling that versus doing a collector job in that way. So if you're pulling data real time, I highly recommend leveraging the S3 source. There are some times you just can't get away from it. So if you can write it out with either file name, having year, month, day, hour, and even down to the minute, that would be awesome. Otherwise, if collection is not as efficient as it should be.
So Brendan, two questions. So in Logstream, when I define that time when I'm running a collection job, if the structure of when the data was written has date, month, time, whatever, it will automatically use that structure and it will not go into the actual raw events of the log. Did I understand that right?
To an extent. So with this here, because this is based on
That only goes to an hour. So,
an hour. So we're going to pull back. If you said last 15 minutes, I have to collect everything for the hour.
Understood.
That is the smallest window that we can possibly use
Perfect.
to define what the events are that we need to look at. So we're only pulling back all of the files for this hour instead of, a full day or month.
So the
but
second
at that
question,
point, yeah, go ahead.
The second question, when you had added file to the destination on the partition expression, obviously if that file name has some information that would help us, filter down searching, great. Is there any downsides to, you're making a heck of a lot more folders inside that S3 bucket, right? Is there a performance hit there or nothing to be concerned with?
There
Making
is
that path longer.
Yeah, there is a theoretical limit on what the full path size is. So here's another item of wisdom. S3 actually doesn't have folders. This is a prefix to the file name. So there is a limit to how long your file name plus the prefix can be.
Okay.
So you don't want to go too far into having too many individual folders, just because then the API gets a little bit wonky with that, and you may not.
And
be
I
able to
asked
save
because
files.
like me, someone's going to say, well, I don't know what I'm looking for until I need it. So I'll just build in a whole bunch of stuff. Like there's certainly some counseling there we could provide, right?
And again, that's the trade-off of, what are you trying to do? How frequent is this collection going to be? What is the cardinality of sources and source types and all of that? So I would highly recommend at least having something down to the day, if not the hour. That's not going to create too many folders, and then having the source type or host or something like that inside
Awesome.
there. What are basically the question is, what are the filters that you're going to use? Host, wow, I can't type.
Would those generally match up with the filters and the routes and the pipelines? I mean, those seem to make logical sense. Or
similar, yeah, depending on what you're trying to do here. So this filter, depending on how you have it configured, if you're using, let's say, host, if I had host inside here, then I could limit the files that need to be returned. So I'm only looking for the host setting, where in that case I had Joe inside the host. So it would only look inside this prefix path. Yeah.
cool. Thank you.
Yep. And David's commenting here, max file name length is 1024 characters, so 1 KB. Yep.
The last one of result routing.
Yeah. So the other thing to consider too, is you're running collectors, is how do you want to set up the result routing? So in this case, I can configure sender routes as yes. I can choose a pre-processing pipeline similar to how you would have a pre-processing pipeline on a source of data. You can also configure throttling if you only want a certain amount of data coming out, because this could be a very high volume coming out at one specific period of time. Or if you don't want to send this to routes, you could configure a specific pipeline and a specific destination. So it'd be like configuring a route right here inside this collector job. So just how do you want to configure the data going out? If this is not set to yes, obviously you need to define this. If you set this to yes, then you can configure things like collection, demo collector. And so if we look at the routes, you'll notice this first one here, collection is demo collector. So you can use meta fields inside your routes and pipelines to be able to do filters based on this data.
So that result routing would, pour it back in the top of all your routes if multiple things had to get done to it, or if I just wanted to do like a security audit event or something, and I knew I just wanted to forward it right off to a particular pipeline and particular, index or destination, I could do it that way, right?
Exactly. And this is useful for scenarios. I'll pick on Splunk, for instance. Let's say you cut your retention in Splunk down to 7 days for an index, just as a theoretical example or hypothetical example. So what you would end up doing is, if you were to replay data from 30 days ago, it would automatically expire that data and throw it away if you ran the collector. Well, that's not what we want to do. So your result routing here, you would have a specific pipeline to say, add this to a different index. So maybe a custom retention period for replayed data. And then you have the destination configured as something like Splunk. So this would be a great way of being able to handle that type of scenario.
so useful. We talk about how to do this stuff in demos, but we haven't actually had experience, or at least myself, how to actually do it. So awesome.
Cool. We got about 30 seconds here to the top of the hour. So I will say thank you to everyone for joining and listening to me ramble today on AWS and collectors. This has been a great time. I hope you learned a little bit. So we'll make this recording available in the community. We're always looking for more ideas. So if there is something of interest, please post to general or office hours in the community Slack, and we're happy to take those as future topics. If you have a question specifically for me, find me on community. I'm Brendan, Cribl.io. If you would like to send me a direct message or post in the general room, I'll find you. I respond to a lot of stuff. So yes.
Well, that was spooky. I will find you. And also perfect. It's the top of the hour, like exactly an hour. Perfectly done, Brendan. Thanks a lot, everybody.
Thanks, everyone. See you next time.